Today's topic is scattering of light. When light falls on very small particles, tiny particles, then diffuse refraction takes place. This diffuse reflection is known as scattering of light. When light falls on very small particles, then diffuse reflection takes place. This phenomenon is known as scattering of light. Is known as scattering of light. Scattering depends on the size of the particles. When the size of the particle is very small in comparison to the wavelength of light, when the size of particles are is very small, then the intensity of scattering will be more. The intensity of scattering will be more. According to Rayleigh, the intensity of scattering depends on wavelength. It is inversely proportional to the fourth power of wavelength. Intensity of scattering is inversely proportional to lambda to the power 4. Here, lambda is the wavelength of light. Lower is the wavelength, higher will be the scattering. It means if we fall white light on the particles, small particles, then the violet color will scatter more. Wavelength of violet color, its lambda for B, is less than the wavelength of red color, its lambda R. It means when white light falls on the small particles, then violet color will scatter more in comparison to the red color. If we increase the size of the particles, if we increase the size of particles, then the scattering of other colors, means red, orange and so on, will also increase. The scattering of red, orange and other colors will increase. If the size of the particles is more, then all the colors will scatter equally. If size of the particles is more, then the scattering of the light of all colors will be equal in amount. Now the phenomena depends on the scattering of light. Your application on scattering of light. The blue color of sky is due to the scattering of light. Blue color of sky is due to the scattering of light. Reddish color of sun at the time of sunrise and sunset and sunset is due to the scattering of light by atmosphere. Now this one is Earth. It is atmosphere, layers of atmosphere, We have the layers of atmosphere. Now suppose here is sun. Sunlight falls on Earth's surface. Means first of all it will enter in the atmosphere. In atmosphere there are dust particles, water droplets, and gases. So they will scatter. Now light scattering for blue color will be more because the wavelength of blue color is blue, violet, and indigo is less, will be more in comparison to the red color and orange color. So when light enters in the atmosphere, the scattering takes place. Most of the colors, blue, violet, they will scatter in the atmosphere. They scattering. The rest color, that's red or orange, it will reach. Here is observer. So the color of sky will be, it is blue color. It appears blue. Of violet, blue, and indigo colors. So the color of sun it appears reddish. Same thing will be at the time of sunset. It is responsible for blue color of sky. Here is observer. The color of sun it appears reddish, yellow, or orange. Now the rainbow. Generally, at the time of in rainy season, we have seen the arc of different colors in the sky. It is due to the reflection of light and also the splitting of the white light into its own colors by the droplets of rain. Suppose after rain, very small drops they will fall slowly. These are the raindrops falling slowly. Sunlight falls on these drops because sun is very far from us, so rays will be trapped via the sunlight, sun rays. These are the rays. Here is sun from sun. When this light enters in the drop, it is divided into 7 colors. Also divided into 7 colors. Here 2 times interval reflection takes place. This one is violet color. The red color will be here. It is red. The same drop here will be violet will be here. There is a red color. This one is violet color. Here is observer. This angle is 53 degree. This angle is 50 degree. In these drops A and B, partial internal reflection takes place 2 times. First time is here and second time is here. Also in this drop, B drop is 2 times. But in this drop, the internal reflection takes place only 1 time. Is also in 1 time. The red color, it is violet. Here will be red color and violet color will be reach on the observer eye. Here is violet color. This angle is 40 degree. This angle is of 42 degree. Now, when internal reflection through the drop takes 2 times, then this rainbow is known as secondary rainbow. but only internal reflection takes place single time when removed as primary rainbow. During the through the drops there is no TIR. TIR not takes place. Total internal reflection does not take place. Only partial internal reflection. During internal reflection, some energy is absorbed. In drop A and B, energy is absorbed two times at this point and this point also. So the intensity of the secondary rainbow will be less in comparison to the primary rainbow because the internal reflection takes place only single time in a drop. So energy is absorbed but less in comparison to the drop A and B. The colors of primary colors, upper color will be red, lower color will be violet. But in secondary, upper color will be violet and lower color will be red. This clears that the intensity of rainbow of primary color will be more in comparison to the intensity of secondary rainbow due to the internal reflection. Now there are the 3 points. During the rainbow formation of rainbow, the formation of rainbow, following phenomena takes place. Number one is refraction of light. Number two is dispersion of light. Of light means the light, white light, sunlight splits into its seven colors. The third point is partial internal reflection. Here, all the seven colors will be between in secondary rainbow that violet and red, and in primary rainbow all the seven colors will be red and violet. This one is violet, means we see the all the seven colors in rainbow in primary as well as in secondary. But the intensity of the colors will be more in the primary rainbow in comparison to the secondary rainbow.